Good morning, students. How are you all? In the previous lecture, I have discussed the effect of temperature on the states of matter. If we are taking a solid state, that is ice, and when we increase the temperature, what we find that after some time the solid ice melts and it converts into the liquid state. After that, if we increase the temperature further, we obtain that the liquid state converts into the gaseous state. That means by increasing or decreasing the temperature, we can change the state. Similarly, if we decrease the temperature, what will happen? The gas converts into liquid, that is called condensation, it condenses. And after that, again when we decrease the temperature, so what will happen? The liquid freezes and converts into solid again. In the same way, I have told you sublimation. Solid directly converts into gas and gas converts into solid without converting into the liquid state. That is the effect of temperature. Now today the next topic is the effect of change of pressure. Pressure means when we are applying pressure on any of the substance, will be there any change in the state of matter or not. Just see, we know that in solids there is a strong force of attraction acting between their particles. That means they are tightly packed. When we apply more and more pressure, so ultimately what will happen? It breaks, but we cannot change its shape. In case of liquid, they have less force of attraction as compared to solids. That's why the liquids can easily flow. In the same way, if we are talking about gas, in case of gas, then there is negligible force of attraction. The particles are far away from each other. They move randomly in all the directions. Now we are seeing the effect of change of pressure on the particles of gas. You have heard about LPG, liquefied petroleum gas. That means it is converted into liquid state. Now how? Let's see the effect of pressure. For this we are taking a container. This is a container in which we are enclosing a gas. These are the gas particles. We know that the particles of gas are far away. So these are different particles of gas which are far away, and there is a movement of particles at a very high speed. Now we are putting it in a container and we are applying pressure by the help of this piston. Fine. That means we are increasing the pressure on the particles of gas along with cooling. That means we are decreasing the temperature and we are increasing the pressure. At the same time, when we do both the things together, so what we find, after some time the particles of gas which are far away from each other, they start coming closer. That means by compressing, by applying more and more pressure, and by decreasing the temperature, the particles of gas which are very far away, so by compressing they comes closer, and by cooling, so when we cool them, the particles which are moving very fast, their kinetic energy becomes slow, and slowly their speed becomes slow and they comes closer. Understood? In that way, the particles comes closer in this way. Fine. Here the particles are far away, and here the particles comes closer. Their speed also decreases, kinetic energy decreases due to cooling, and by compressing they comes close. Fine. After that we compress it further more and we cool. That means decreasing the temperature again and by applying more and more pressure. After some time we observe that the particles of gas come so closer and the movement stops. And what will happen? It stops or it becomes very slow. So in that case, what we find, the particles of gas come so closer that it converts into the liquid state. That means we can easily liquefy the gases by applying more and more pressure and by decreasing the temperature. Now students, we have heard about solid carbon dioxide. Solid carbon dioxide is stored at a very high pressure. Now when we decrease the atmospheric pressure up to 1 atm, then we observe that solid carbon dioxide directly convert into the gaseous state without converting into the liquid state. That is why solid carbon dioxide is also known as dry ice.